Well, thank you, everyone. It's great to be here in Barcelona at one of, I would say, the biggest events and one of the biggest forces actually impacting our world, right? The technology world. And that clearly is the Internet of Things. So Garret and myself are going to talk a little bit about IoT, all of that in the context of analytics at the edge. Some have said, and I believe, that the IoT, Internet of Things, is the enabler of the fourth industrial revolution. It's that big. I mean, that's why we are here. You can see out in the application showcase all of the different supply chains of vendors and providers and integrators out there. So this is really the next big thing. One of those parallel changes, a major change going on with this fourth industrial revolution that I would submit to you a lot of us haven't really thought about, but I want to share a few thoughts with you to get that into your head as Garret and I then speak a little bit. It's this concept of the analytics economy. In the analytics economy, it is defined by a pervasiveness and an acceptance of analytics. Now, sometimes in an economy, and sometimes in the technology world, analytics is, oh, I'll get there at some point to get value. But with IoT, I submit that analytics is the driver of value. So pervasiveness and acceptance of embedded analytics, and those analytics are driving those decisions. So the keys to an analytics economy are data, and we know we have plenty of that in IoT. Analytics, we'll talk a bit more about that. And the third one being collaboration. Collaboration in this case between people, of course, but also between machines. And clearly, as we talk about the network effect and how all of the value of the IoT comes together, collaboration with all the data and the analytics in a connected system is really going to drive the value. So those keys are data, analytics, and collaboration. And the question then becomes, how do we take advantage of that? How do we actually leverage those? And from our perspective, the best way to leverage those is with a life cycle. And that life cycle is the analytics life cycle. And this is something we've pioneered at SAS. It's pretty straightforward. It's three major phases, as you see here on the slide. There's data, discovery, and then deployment. And these phases are all managed, they're all governed, they're part of an enterprise-wide process, but they are not, and I repeat, they are not a rigid step-by-step process. That just does not work. We've seen it not work for years in core IT and core application development. It surely does not work in IoT. So it's a cycle. It allows for innovation. It allows for self-improvement. It allows for iteration of going through cycles of understanding the data that you now have, the analytics that need to be in place, and the ability to deploy that, and in this case, deploy it out to the edge. The whole premise of our conversation today is, yes, decisions at the cloud, decisions at the data center still matter, but the value is to have those decisions out at the edge. And being able to bring together a life cycle that is managed and governed, yet open enough to drive those decisions and allow us, as key members of the decision cycle, to operate, is really the value proposition. The one thing I will say is data is a huge component here. There are many folks today, not by ill intent, not for the wrong reason, are creating what I like to call a digital attic. You know that room above the house or the flat that you store stuff, and you're not quite sure if you need it, but it's there. We're doing that a lot right now with data. We're bringing it in from all of our sensor devices. We're either storing it at a midpoint, dumping it into the cloud, or maybe filling up disk arrays in our data center. That's really not the answer to solving business problems in IoT. The other concern point is there are some folks that are looking at analytics maybe at an individual scale, or they're even running the analytics and not deploying them. That's an academic exercise, and it's not really driving commercial value. The value in this life cycle comes when the data, the analytics, and all the deployment are in harmony, And they are operating in a very quick cycle with low latency. Decisions are where the data is. Latency is very minimal. So that means we have to push the analytics out. So in that case, analytics has what I would say is the unique power to propel IoT beyond a connected world into a smart connected world. So I would also say that IoT could stand for the intelligence of things. Because yes, connectivity is important. As a matter of fact, it's fundamental. We wouldn't be here right now if we didn't have all the innovation and all the evolution in a connected world. But connectivity itself is not enough. We've got to have the analytics. We've got to have the intelligence that's brought into this network. And when that network is lit up, if you will, through an intelligent environment, then the devices, the systems, and ultimately the end result is that much better. So again, being able to deliver the analytics out to the edge is very similar to the human brain. Right? That's where the data is stored. We've got lots of sensors in our system. We're bringing the data and storing it. We're making the decision point there, and then we can push that back out to, I would say, the edge, the execution of that. So if you think of this model, this environment is really only effective when that network is intelligent, connected, and we've got that process moving. Now, I think everybody else would recognize here that IoT is all about the ecosystem. And we at SAS adamantly understand that and recommend that. So from our standpoint, we've worked very closely for decades. We're a 40-year-old software company, and we're 40 years new now, with IoT being a huge driver behind how we take analytics to market. We've worked with Intel for many years. We're working with them now on IoT. You can actually see that throughout the conference on how the edge device is intelligent, it's got compute power, it's got storage power to it, and it's actually helping drive those decisions. So in a moment, we're going to talk a bit about a use case with Garret from GE Transportation that's probably familiar to us. It's heavy industry with high value assets, huge money at stake for driving operations, safety, and efficiency. Much like heavy industry, supply chain, industrial IoT. Before we go there, I'd like to spend a few minutes on a couple other use cases to just set some context and make it relevant to everyone here. First one is smart medicine. So smart medicine is really driven by, for example, about $200 to $300 billion in wasted money every year because of non-adherence to prescribed regimens. Doctor's orders. We as creatures who have said we've got access to first-class health care, we are willingly going to the doctor, but we are not keeping up our end of the deal when we get a prescription and a regimen to take the medicine and follow it. Hundreds of billions of dollars wasted every year. So, there's quite a few organizations out there. One of them is called Proteus Digital Health. They have a smart pill platform, so it uses ingestible sensors. So a couple things go on there. One, you're taking your medicine, you also ingest this very small sensor. So check. It's now keeping track of, did you follow the regimen? And it's also keeping track, in some cases, of the efficiency of the medicine itself. So the pill delivers the medicine. The sensor tracks adherence to the regimen and effectiveness of the drug. You can get that yourself on your own personal device. You can also share that with your provider. So an individual patient getting treatment, the provider actually seeing how the patient is following orders, and then the network building up. So there's one example. The next one relates to something that I submit we're all interested in, eating, in our food supply. There's actually some interesting content out on the showcases around honeybees. So 1 out of every 3 bites of food that we take is a result of pollinators, natural pollinators, like honeybees. So 1/3 of our food supply. And you might have heard that the honeybee population around the world, and definitely in my home country of the US, is plummeting. It's actually lost about 1/3 of the population in the last 4 to 5 years. So that is directly impacting our food supply, our long-term food supply. So what are we going to do about that? Well, one is we can actually measure and understand a little bit more of what's going on in the hive, and that is absolutely one way to do it. And one organization is actually taking that, I'll say, a step further out into the connected world and actually measuring some of the bees in the hive. So in this case, the bees have a sensor on them. It weighs 5.4 milligrams. This sensor tracks distance away from the hive, time away from the hive, environmental aspects like food, water, air pollution, all of those things like disease that are actually killing off the population, they could track through the sensor. It's powered through vibration. So the bee's vibration itself is keeping the sensor alive and feeding back into the network. So in this case, and in the earlier case, obviously the value of keeping a patient, us, healthy, absolutely makes sense. The value of a bee or a beehive might make sense, especially in your country if it's helping produce food, but obviously in the world it's helping. But the value comes in the network effect. The value comes in the network effect. So having all of those patients, bringing that pool of data together in an anonymized way so that the provider community, maybe the research community can actually build a better drug, create a better antibody, whatever the case may be, but the network effect is really driving it. So with that context, in those two examples, I'd like to introduce Garret Fitzgerald. And Garret is the general manager of GE Transport. And Garrett's going to come out and talk to us a little bit about a heavy industry. He's leading an initiative with GE Transportation in connected device. And in this case, it's in the locomotive industry. The locomotives are connected, they're part of a network, and it's driving real business value for their customers. So please, Garret, come on out and join me.
Great.
Thank you for being here.
Thanks.
So I know a lot of us here in the audience are familiar with GE and General Electric. Some may or may not be familiar with GE Transport. So start out a little bit, if you would. Give us some insight into GE, what the parent company is up to, and what GE Transportation is doing.
Yeah, I mean, so over the last decade, the overall GE portfolio has changed quite a bit, right? And we've really deepened our presence in big industries like oil and gas, power and water, expanding our footprint, getting deeper, and also transportation. And at the same time as we've been getting deeper into those big industries, we've also been on a digital transformation over the last 5 years, really investing heavily in making digital a core component of each and every business, as well as its own big vertical to invest in the platform. And so GE Transportation, the business that I'm a part of, has for 100 years been a freight locomotive business. And really you need to think about a very difficult, hard industrial environment in which these locomotives operate. We've also been primarily North America focused. But over the last 5 years, like GE overall, we've been on a digital journey to digitize our assets, but also digitize our customers' entire environment. And that's really where Transport Intelligence, my business, comes in, where we've put together a set of products all the way from edge devices to device management, partnered with SAS now on business rules engines and analytics, as well as our APM solutions in the cloud. Right? And so we've put them all together so that we can really provide that cohesive solution offering around IoT for our transportation customers.
And Garret, I think that hits on the point I mentioned early on about, one, an ecosystem, and I know we'll talk about that in a little bit as well, but the fact that you put an environment together out in the wild, and I think it can't be understated that in the freight industry, these locomotives and the train itself, they're not always sitting in the city, in the yard, so they are out in the wild, hauling a lot of freight.
Right.
There's a lot of money tied up on this, but you put together an environment where not only you've got the locomotive connected, but you're able to deploy software updates to it, in this
Yep.
case, some of the SaaS analytics and the SaaS model,
Right.
as well as what GE has in place.
So I'll just quickly, for everybody in the room, I'll give you a couple of North American statistics alone to give you a little bit of a sense of scale for the industry. So you can expand this kind of globally in your mind, but North American transportation industry is a $900 billion industry, of which freight rail is about 10% of. Right, and at any point in time, there's 26,000 diesel locomotives going around North America right now. And in addition to that, it's a big, heavy industry. So the stat is that the longest train in the world right now is over 7 kilometers long and hauling 100,000 tons of freight. So
where do you put a train like that? Where do you put a
Yeah.
7-kilometer train?
So this is actually one of a mining company that runs their own railroad as well, and so they're hauling that commodity freight. And so just imagine now putting compute into that kind of environment, right? I mean, this is not your data center that's humidity controlled, air conditioned, stationary. It's always mobile, and it's big and heavy.
It's a rolling data center.
A rolling data center.
So in that environment, right, you've got a well-connected device,
Yep.
Obviously heavy industry out in the world. How do analytics fit into an environment like that? Because obviously connectivity is important first off, but how are you bringing analytics into that environment? And what are some of the drivers that you're seeing in your customer base? Because obviously GE Transportation is serving the rail industry in this case.
Right. So we have two big decision points as to whether we're going to run analytics at the edge, right, or in the back office. And they're very prevalent in this industry. One is obviously where the data resides. And so we find that it's often not possible to offboard all of that data fast enough to drive decision making offboard and then send it back to the locomotive. So the more decision making we can put at the edge, the better, because that's where the data is. The second is the real-time nature of the insights that you're going to develop and then actually drive action in the physical world, right? An insight is fantastic, but if a person or a machine doesn't have that insight in the exact moment when they can act on it, it's essentially not worth having. So you need to have it at the edge, real time, when the decision and the action needs to be driven. And those are some of the challenges that our customers are facing as they try and push analytics out to the edge.
Right, and in that case, there's a couple major, I'd say, drivers in their world. There's competition, right, in the business itself.
Right.
And then there's regulation, especially in the rail industry, passenger and freight. Right, and those are two big aspects that are impacting your business and your customers.
Right. Yeah, I mean, our customers globally, in terms of the railroads, freight railroads, have a big economic challenge right now, in that their most profitable and highest volume carloads are decreasing, right? So think coal and commodities like gravel and sand and the big heavy freight. And as those decrease, they need to do two things. One is they need to find ways to take cost out and become more efficient. They also need to find ways to generate new business and new carloads, and that's really about becoming more reliable. The other thing, and this is more North America centric, but is regulatory and the positive train control regulation. And for those of you that don't know, North American railroads right now are spending over $10 billion putting compute and sensors and devices out onto their locomotives as a regulatory form, right? So this is an easy example. A train enters a town, it should be going 20 miles an hour. It's going 30. This computer knows that, generates an alert, and if something doesn't change, it stops the train. What this also does, though, is it introduces hundreds or thousands of new failure modes, because if those devices fail, stops the train, right? And so not only are they spending a ton of money, but they're increasing their failure modes. So they're really looking now, how do they change that and have a paradigm shift to using this to generate value and to generate productivity versus the opposite.
So as you said earlier, that's a massively hardened environment. And as you put more of the decisions, whether they're regulatory or business, out in that device, it puts that much onus on this ecosystem,
right?
To make sure it's secure, but it's also high available. And a lot of these devices are not near Wi-Fi and cell coverage all the time, so you've got to have a system inside of it to do that. So let's talk a little bit about the solution that you put in place. I think that'll help the audience get a feel for this ecosystem. right? GoLink and EdgeLink are the GE systems that you've got in place, obviously with SAS being part of that, and quite a few others in the ecosystem.
Right. So we have what we have at our core in terms of the GE produced software and devices, our GoLink product line, which is really heavily ruggedized compute and devices that we're putting out onto the locomotives. We also now have our EdgeLink software suite, which is really around device management. And that's where, and in those two product lines is where we've integrated the SAS ESP rules engine and analytics tools to either run analytics at the edge on the GoLink itself, or in the back office as a part of EdgeLink. And then also our APM solutions. And what we believe in is that it's not just the GE components in each of those three areas, but also developing an ecosystem of device partners, software partners, so that our customers can now implement these IoT solutions in an efficient way. Because what I always say is if you have a $10 million business value, that doesn't mean anything. It's going to cost you $15 million a year to implement and run. All right? And so we've got to find ways to decrease that integration cost, and that's where the ecosystem comes into play. And the strongest ecosystem, I think, is going to be the one that's going to win in this space, because it will decrease that integration cost for our customers.
So you've shared some numbers on the industry, which should help give us some scale of it. And in this case, North America is spending $10 billion plus just on regulatory drivers.
Yeah.
So let's talk about the value proposition, right? Sometimes it's top line revenue. Some cases that you just alluded to are cost savings.
Right.
Talk a little bit about the money and the value that your system actually is going to bring to your client base, and,
Yeah.
and really the business case for you guys putting a line of business into the market.
Right. So we'll just jump right to it. You know, the North America freight railroads spend $10 to $14 billion a year on fuel alone. So you can imagine what we can do now with analytics running at the edge, oftentimes very simple analytics, to improve their fuel usage. A 1% savings on $10 to $14 billion is a massive impact for our customers. And again, this is North America alone, so you can just imagine as you expand globally, you know, that number grows significantly. And so that's the challenge is how do you get those analytics to run at the edge, though, again, where that insight needs to be generated. You know, knowing in the back office that your locomotive has been idling for 10 minutes doesn't help you actually change the behavior. But in the moment, knowing, hey, this locomotive's idling and alerting someone at the edge to go shut it off, that can be a big savings. I mean, even the little things like that.
Right. And in that case, it's not just the engine's idling, right? You have geofencing technology in there, you understand location, you understand routing,
right.
All the additional technology in there. Touch on that a little bit.
And that's really where the SAS ESP capability has come in, and I think is getting our customers really excited, is not just about the things that they know how to do today, but the capability to do a lot of things across their network that they couldn't do previously. You know, rules around geofencing and geozones, you know, knowing that these locomotives have all entered into a service shop, and therefore you can apply a different rule set to them to monitor them differently than the locomotives that are out actually running on live track. The other thing is this concept of dynamic groups that they haven't been able to really effectively achieve across the fleet of locomotives. So dynamically creating those groups of these locomotives are in this space, so they should have this rule set. Or these locomotives have these devices installed, so apply this template and these set of rules. Today, that's all very manual, very hard-coded, and what we've implemented with EdgeLink device management and SAS ESP is the ability for them to now go in and make those changes and those configuration updates themselves. Right? They don't have to call their IT vendor
right.
to come in and change code anymore. They can do it themselves in a configurable and easily deployable way.
In that case, though, it's a managed environment for them. They're not going back and either reconfiguring, or I would even go as far as saying re-architecting and reintegrating.
Right.
They're able to drop that rule set in, or some of those rules are even driven by the analytics in the system and the network itself.
Yep.
I think one of the things that Garret and I talked about, the network itself changes every minute, every 15 minutes, because the locomotives are moving, and we get it, you know the routes, you know where they're going to go, but sometimes decisions have to be made, and these are big dollar decisions, right? The other one, obviously that's a lot of money in fuel savings and other drivers. Sometimes it's time to market, right? I think one of the things we saw as you put together a pilot for one of your customers, it wasn't years for them to put it together and see the value.
Right.
It was, what, months, right? Share a little bit of the project and how having a managed environment really helped.
Yeah, I mean, we were able to, when we started working with SAS, our developers went from having never touched or played with the tool to really integrating it into our EdgeLink solution and demo it to a customer within a few months. And so that was incredibly powerful in terms of being able to not just talk to them about capability, but really show them some of the rules that they had been struggling with implementing live in a system with simulated data, right? And so, it's very much so about time to market, something that's easy for them to deploy. And I'll also just say that's why we're also trying to build an ecosystem of device partners so that it's not OEM centric, right? I mean, we don't want to be a GE platform for GE assets and GE customers only, right? It really needs to be an open ecosystem where we can manage our own devices, but also manage third-party devices and allow our customers to run the rules engine and generate business value from their whole ecosystem.
So a good point there to build on. There was a Cisco survey several months ago that said nearly 3/4 of all the IoT projects are either failing or they're not delivering on the value that was expected, right? And some of that is the ecosystem and the deployment and the management. So talk a little bit about, maybe in reference to that, how that projects are successful and what you guys are doing to make sure they are.
Yeah, I mean, my background in GE, I actually came up through the IT organization, so I still tend to approach problems with a total cost of ownership mindset. And I fundamentally think most IoT projects out there are failing today because we don't spend enough time thinking about all of the integration costs associated with bringing together point solutions required to achieve a business outcome. We spend a lot of time talking about the business outcome, and we should, but we need to spend more time and continue to focus on how do we achieve that efficiently. And to me, that's where an ecosystem comes into play. It's where creating the plug-and-play mentality is. Right? My simple example for everyone is just think about when you tried to install your home printer 10 years ago, right? How customized and complex that was. Finding the driver, plugging it into the right port.
Bringing back nightmares.
I know. Well, now try to imagine doing that across tens of thousands of mobile assets, each running 30 devices apiece, running all around the globe. So now you're not doing it in your own room, but you're doing it tens of thousands, hundreds of thousands of times across mobile devices. And you can see how the cost builds in that, right? And so we need to make it the home printer of today, where you connect it to your Wi-Fi network, you plug in your laptop, it automatically finds the drivers, and you're up and running in 30 seconds. So that's the paradigm shift we need to make in the industrial space too.
And I think the other point there, Garrett, is as new rules come out, as new assets go online, adding them to the network has to be as simple as adding that printer to the network now.
Exactly.
Otherwise, it's years to add another set of locomotives.
Yep.
I know one of the customers you're working with, started with X hundred. They're going to add X hundred more over the course of time, and that time is not a decade, right? That's 3-month tranches of putting 100 more out, 100 more out. Yeah. So that kind of speed is part of the process as well.
And you talked about the analytics lifecycle. If your analytics team is operating iteratively and executing on that well and developing new algorithms and new rules, they want to be able to push that out into production. They don't want to wait 6 months for a locomotive to come into a service shop for a physical touch. They want to be able to update that real time and achieve that business value.
Yeah, they don't have the time, right? Especially in that kind of environment, they got to get the freight there. So I mentioned briefly in the beginning and used some fun examples around connected medicine and bees to highlight this network effect. And you touched on it a little bit with a fleet out there for one of your customers. Talk a little bit about network effect and what you're seeing now as the value proposition.
I mean, I think we're seeing it in terms of, I'll tee it up in two ways. The devices that go out onto these assets often have a hierarchy. So there's the network effect just for one locomotive alone, all kinds of sensors and things that are coming together, often brought together in a more high compute device and networked on one locomotive. There's also then, though, this ability to generate rules and have alerts between locomotives at the edge. I used a service shop example. Another one is how close are those locomotives on the track themselves, right? How close can you run them, getting more precise signals, being able to communicate, hey, this locomotive up here has a failure directly back to the train behind it. Those types of things are very powerful, and the ESP engine is going to allow us to do that real time at the edge, and that cuts out a lot of data movement and a lot of complexity.
And to bring this to a close, we've talked obviously about freight rail and locomotives, but I think it's worth zooming out a little bit. Talk about some of the other industries that you are seeing, and I know we are seeing them at SAS and SAS and GE
Right.
together. I think it gives some context for the audience here.
Yeah, I mean, I've given a lot of sort of my business's perspective and industry view, but obviously across GE, and my personal view is this is an incredibly universal problem. Anyone deploying edge devices, doing device management in big industrial spaces, you're having these problems, and this solution is very transportable, right? So we're going to be applying it across all of our industries as we go forward, just as much as we're implementing it.
Yeah, we're seeing the same thing, and I know that the diversity in the audience is communications and banking, supply chain. So, thank you very much for your thoughts and your insight around GE Transportation, and thank you guys. I think you can relate to a lot of what Garret and team are doing in the transportation business to all the other industries. Hopefully you'll walk away from this session and recognize the fact that the network effect really matters. Analytics in this case need a connected environment. Yes, they're at the data center and in the cloud, but absolutely analytics out at the edge are driving the value in IoT. And this is just the beginning. So there's a lot more on the horizon for all of us. So Garret, thank you very much.
Yeah.
Enjoyed being with you. Yep.
Yeah.
Thank you guys.